Advanced mode for colorless diamonds. To activate the advanced mode, click on the second icon from right at the top of the screen. Now the EXA is displaying in real time the fluorescent spectrum captured by the probe. As you can see, it's only a wiggly line essentially showing noise coming from the environment light. Let's test the diamond, which got a pass in the standard mode. This is the most typical fluorescent spectrum of a natural diamond, and this is the area where we can observe the peak at 415 nanometers and its side bands. As previously said, roughly 98% of diamonds shows these peaks caused by the N3 aggregate. Every time a colorless, near to colorless diamond will show a spectrum like this, we can conclude it's natural. It is possible to zoom this area in order to inspect those peaks more closely. So we have to pause the spectrum and select the area to be zoomed. Now we can activate the cursor and slide it on the spectrum till we find the peak, and then we have its value. As you can see, 415 nanometers. It's important for the operator to familiarize with this spectrum, because the EXA can work faster for screening diamonds if the advanced mode is selected instead of the standard one. We will discuss this at the end of this video. Now it's time to test the stone which got refer in standard mode to see if we can identify it by using the advanced mode. This spectrum is missing the N3 peak and its sidebands completely. Something to notice is this peak dominating the infrared area. We can pause the scan and the database will show up. It will not take much to recognize a spectrum featuring the same peak. To be more sure about the matching location, we can zoom the section and activate the cursor. This peak, centered at 737 nanometers, is caused by a silicon vacancy defect in the crystal lattice of CVD synthetic diamonds. It's a very common feature, almost a trademark of this growth process in which silicon contamination is almost unavoidable. The extent of the peak may vary a lot, so it's always advisable to check that zone carefully. The advanced mode allowed us to identify this diamond as synthetic CVD. Unfortunately, synthetic HPHT do not show specific consistent features, so a combination of other techniques is required for their correct identification. Sometimes diamonds exhibiting a distinct yellow, yellowish-green or greenish-yellow fluorescence can be referred to. They are not uncommon, especially in the melee size. The main reason for the refer is due to the strong reaction often caused by H3 and or S2, S3 defects, which often overwhelms the capacity of the spectrometer to detect the N3 if it's present. In other cases, such diamonds can be pure 1AA, where N3 can be missing or its reaction masked by the A aggregates. Here's the spectrum of a diamond showing a greenish-yellow reaction which have been referred in the standard mode. As you can see, the N3 peak and its sidebands are completely missing. Then we have this huge emission band, which is the graphic expression of the color of the reaction. Another thing to notice: in many of these stones, a diagnostic peak at 794 nanometer can be present. It's another feature, besides the S3 band, of nickel impurities in natural diamonds. So even this referred diamond has been positively identified as natural by the advanced mode. Advanced mode for diamond simulants. The standard mode will of course refer all the diamond simulants, but with the advanced mode we can identify the most popular ones. Here's the spectrum of a cubic zirconia. And here in the images on top left how it appears in daylight and under the EXA probe. Synthetic moissanite is almost always completely inert, so the resulting spectrum is nothing else than noise. This is the reason why a spectrum of moissanite is not present in the EXA database. Here's the spectrum of a natural colorless zircon. These diagnostic peaks are caused by rare earth elements impurities. The database includes even reference spectra of other diamond simulants as SGG and GGG. Testing mounted diamonds in advanced mode. Since in advanced mode the spectrum is displayed in real time and there is no need for waiting the 3 scans performed before to get a pass, it's clear that once we are familiar with the 415 nanometers peak and the sidebands pattern, by using the advanced mode even for screening, the testing speed will increase dramatically. It turns very useful when checking parcels of stone as well. In conclusion, the advanced mode is really effective to reduce the percentage of refer stones and can actually identify synthetic CVD colorless diamonds and even some simulants. It also proved to be 3 times faster than the standard mode once the operator gained a bit of experience in evaluating the spectra.
Thank you for watching this video. For more information about our spectrometers, please visit our website. And if you have any question, please don't hesitate to contact us at info@gemoraman.com.